Hello, Algebra 1. This is section 4.4b, part 3 of our operations with radicals, and today we're going to be adding and subtracting radicals. So let's get started. Okay, so we're going to simplify these expressions. Our first expression, 3 square root of 5 plus 7 square root of 5, we notice that both of them have a square root of 5. We consider that square root of 5 to be kind of like a variable, whereas if they both had an x, then that would make these two terms like terms because they both contain the square root of 5. So if we have like terms, then we just add the coefficients. So we take 3 plus 7 to give us 10, and then the square root of 5 just tags along on the end. In the next example, all of these terms have a square root of 2. So these are all like terms, so we'll just add and subtract the coefficients. So we have 9 minus 4 plus 7, which is going to be 9 minus 4, 5 square root of 2, plus 7 square root of 2 will be 12 square root of 2. In the third example, we have the square root of 6 plus the square root of 13. Now these are considered not like terms, so we cannot simplify any further. This will be already simplified. So we can combine radicals if the radicals are exactly the same, meaning that they have to be the same and be like terms, and then we can add and subtract the coefficients. Let's do some practice simplifying. In number 1, we have 11 square root of 3 minus 17 square root of 13 plus 9 square root of 3. So immediately we notice our like terms, 11 square root of 3 plus 9 square root of 3. 11 plus 9 is 20 square root of 3. And then we will just have that minus 17 square root of 13. Since that does not have a like term, we will just write that next. So our final answer would be 20 square root of 3 minus 17 square root of 3, and you cannot simplify that any further. In number 2, all of these have square roots of 3, so all 3 of these are going to be like terms. So we'll start with 15 minus 6 square root of 3, which is 9 square root of 3, minus 5 square root of 3. 9 minus 5 is our 4 square root of 3, so 4 square root of 3 is our answer. In example 3, we have 6 square root of 7 plus 13 square root of 5 plus 8 square root of 17. So immediately all of these radicands are different numbers, which means none of these are like terms. So if we cannot combine them because they are not like terms, then this would already be simplified. In example 4, we notice that we have square roots of 8. Well, square root of 8 is not simplified. We'll need to break down the square root of 8 before we're able to combine those like terms, those square roots of 8. So the square root of 8 can be broken up into the square root of 4 times the square root of 2. And so for the next square root of 8, we'll do the same thing, square root of 4 times square root of 2. And 3 square root of 10 is simplified because 10 only has factors 5 and 2. Neither of those are perfect squares, so that means the square root of 10 is simplified. So let's continue simplifying our perfect squares. So we have negative 3 times the perfect square of 4. So when you take the square root, that'll be 2 without the radical symbol, times square root of 2 plus 8 times 2, square root of 2, plus 3 square root of 10. So now we'll just multiply our original coefficient times the number that we got from taking the square root. So we have negative 6 square root of 2 plus 16 square root of 2 plus 3 square root of 10. So we've now created a like term. Negative 6 square root of 2 plus 16 square root of 2 will be 10 square root of 2 plus 3 square root of 10. And since those are not like terms, then that is our final simplified answer. In example 5, we start noticing that we have the square root of 48, which does have a perfect square that divides into the square root of 48. So we'll start with our 8 square root of 2 and then break down our square root of 48 into the perfect square combination of square root of 16 times square root of 3. Square root of 16 is the biggest perfect square that divides into the square root of 48. And we know that because if we look at its part over here, its second part, the square root of 3, that can't be simplified any further. So that must mean that the square root of 16 is the largest perfect square. Okay, so we have 8 square root of 2 plus 2 square root of 16 square root of 3. Our 8 square root of 2 will just bring down, and now we'll take the square root of that perfect square, which simplifies to be 4. So 2 times 4 is 8 square root of 3. And since we have a square root of 3 and a square root of 2, those are not like terms, so that is our answer. In number 6, we're going to have to simplify both of these radicals. Again, we can break down the square root of 8 into the square root of 4 times the square root of 2. And 50 can be broken down into the square root of 25 times the square root of 2. Again, 25 is the largest perfect square that goes into 50. So we take the square roots of our perfect squares, which are 2 and 5. So 6 times 2 is 12 square root of 2 minus 10 square root of 2. Now notice, in the beginning of the problem, it looked like that we didn't have any like terms because we have the square root of 8 and the square root of 50. Those aren't like terms, but after we simplified, we've created like terms. Now we have a square root of 2 and a square root of 2. So now we do have like terms. We can combine their coefficients. So 12 minus 2 will give us 10 square root of 2, and that is our answer. So we have the square root of 20 and square root of 45, both of which can be simplified before we decide if we have like terms to combine. So we're going to break down square root of 20 and square root of 45. So we find the largest perfect squares that divide into each of them. So 3 square root of 20 now becomes 3 times 2 square root of 5, and 2 square root of 45 now becomes 2 times 3 square root of 5. We have 6 square root of 5 minus 6 square root of 5. And we have square roots of 5, so then we combine our coefficients, 6 minus 6, which simplifies to 0. And in our last example, we're going to start by simplifying our roots first. Square root of 18 breaks down into the square root of 9 times the square root of 2. And the largest perfect square that divides into 32 is square root of 16. So now we take our square roots and multiply. So we have 15 square root of 2 plus 12 square root of 2. Again, we've created like terms now, so we can add our coefficients, which is 27 square root of 2. Okay, and that completes our examples and notes on adding and subtracting. Make sure that you write down any questions that you have, and you can email me if you have any questions, and try some homework problems on your own.